Okay, so we were discussing the motion of a charged particle in a perpendicular magnetic field. Magnetic field and velocity of motion are both perpendicular. In that case, what will happen, or what direction the particle move, or charged particle move? That is what we were discussing yesterday. Anjan is waiting. Okay. So here you can see a perpendicular. Into mark represent magnetic field, perpendicular, into cross. That represent magnetic field perpendicular to the plane of the paper and into that. Understand? Into mark represent what? Magnetic field perpendicular to the plane of the paper and into that. Into that means if it pierces that sender into that mobile, into the mobile, like that, or into the book, like that. That is a direction. So magnetic field direction is perpendicular to the plane of the paper and into that. Okay, and then velocity of the particle is actually moving perpendicular. Particle is moving perpendicular to that, like this. One is into, one is in this direction, opposite, 90 degree, making 90 degree. So we know when the particle move perpendicular to the magnetic field, F equal to BQV sin theta, or F equal to vector F equal to Q into V cross B, and F is perpendicular to V. F is perpendicular to V, and therefore it do not do any work on it. That force do not do any work on it, and there is no change in kinetic energy. Velocity is not increased. Only the direction of motion is changed. So the particle move in a circular path. That is shown in that figure, blue circle, no? So particle move in a circular path of radius r. And for any body to move in a circular path, centripetal force is required. And centripetal force formula we know, mv square by r. And that is provided by this magnetic force. Centripetal force required for that particle to move in the circular path is provided by this magnetic Lorentz force. Okay, BQV. Why sin theta is not taken here? Because angle between B and V is 90 degree. Angle between B and V is 90 degree. So BQV sin 90. Sin 90 is 1. So that is why sin theta is not taken there. Sin 90 is 1. So and all the conditions are for that particle is moving perpendicular to the direction of magnetic field. So it experiences maximum force. That maximum force is BQV. Okay. And centripetal force required is provided by this magnetic Lorentz force BQV. Therefore, r, radius of the particle, we can calculate mv by bq. M is the mass of the particle. Q is the charge of the particle. So for that particular mass and charge of that particle, this will be the radius. So if charge to mass ratio that is different for another particle, radius also depends on that. Otherwise, for that particular particle, that is constant. For M and Q, for all particles having same charge to mass ratio, that radius will be same. Time taken to complete one circular motion or period, that is the time period. What is time period? Time taken to complete one circular motion, that is time period. So time period we know, so total distance by its velocity, the total distance is 2 pi r. 2 pi r is the circumference of the circle, 2 pi r by v. So 2 pi by v into r we can substitute above value, r equal to mv by bq. So you get that expression 2 pi m by bq, 2 pi m by bq, very important relation. Time period equal to 2 pi m by bq. Clearly the time period is independent of velocity and radius. Time period is independent of velocity and radius. See the particle, whether the particle is moving fast or not, that time period is not depending on that. If it is faster, it will cover more radius like that. So time period do not depend upon velocity and radius. Time period, in that expression, no radius is there, no velocity is there. 2 pi m by bq. For the same charge to mass ratio of the particle, they will complete the circular path. Whether it is fast or not, that will complete the circular path in the same time. So frequency of revolution 1 by time period equal to bq by 2 pi m. Frequency of revolution is 1 by time period, that we know, that is equal to inverse of the above value bq by 2 pi m. This frequency is called cyclotron frequency, but you know cyclotron is deleted portion. Actually it is a lengthy experiment. Usually asked as a 5-mark question, but that much important it was. And but according to new syllabus, cyclotron is not there. Okay, so you need not study cyclotron. So actually after this portion we usually take that cyclotron, but now deleted. Cyclotron is deleted. So next, when the initial velocity makes an angle with the magnet. So we have discussed 2 cases. When the charged particle move in the direction of the magnetic field, theta becomes what? 0. So force experience will be 0. When theta is 90, it experiences force, BQV. BQV is the force experience, and we have studied. Yes.
Shivagange not meeting.
Ari Shivagange idillillo listile kannilla, not in this not in this list, but other 3 were there. Okay, no problem. So next case we are, so one is 90 degree discussed. We have discussed when B and V are 90 degree, and that is what we have seen now. Particle move in a circular motion. And the other case we have discussed is theta 0, B and particle move in the direction of magnetic field. So BQB sin 0, that becomes 0. Force is 0. It will not experience any force. Okay, no force. It can move with uniform velocity, but no force, no acceleration. Okay, no force moving, but no force. This magnetic field will not give any force, act on any force on it. That's the case. So 2 cases we have discussed. And the third one, when the initial velocity makes an angle with the magnetic field. So other than 0 and 90, there are so many other angles between 0 and 90. So if a particle is moving, making an angle theta with the direction of the magnetic field, what is the case? That is an interesting case. When it makes an angle theta with the direction of the magnetic field, what happened? This one. Okay. And figure is next page. Figure I will show you first. Figure is this one. Okay, figure is this one. Okay, I will explain figure. So here you can see that orange colored line, that is the magnetic field, uniform magnetic field. We have drawn only one line of force, magnetic field. And then velocity also shown. A charged particle is moving with a velocity v. Its direction is also shown, making an angle theta with the direction of the magnetic field. It is also shown. And velocity is having 2 components, we know. One component, nearby component, that is cos theta. V cos theta is acting along B, and V sin theta is perpendicular to B. So magnetic field vector is there, velocity vector is there. V and B make an angle theta. V is having 2 components, V cos theta in the direction of magnetic field and V sin theta perpendicular to the direction of magnetic field. That is the first figure. Second figure you see, right side figure, that is due to these 2 components of velocity, V cos theta and V sin theta, 2 components of velocities are there. what is happening to that charged particle? That is very interesting phenomena takes place. You can see, we know V cos theta component is in the direction of magnetic field. So it will not experience any force. That particle move with a constant velocity V cos theta. It will continue to move, particle continue to move with a constant velocity V cos theta in the direction of magnetic field. Okay. But you know, due to the perpendicular component, what will happen? That particle will complete a circular path. So perpendicular component of velocity V sin theta. Due to that component, what happened? Particle's direction is changed and it move in a circular path. So two types of motion is there. Two types of motion are there. One is due to the V cos theta component, particle move a linear distance. At the same time, due to the component V sin theta, it move in a circular path. So what type of motion we can expect? By the time particle complete one circular motion, it move a linear distance. Next also, by the time particle complete next circular motion, it moves certain distance, like that. So what will be the nature of the path? It is shown in that figure. Helical path. It is helical path, you see. By the time particle complete one circular motion, it move a linear distance. Apart the circle. Next circle complete, it move a linear distance. It in between you can see that circle there is a distance. So this is the path known as helical path. Helical path. Helical spring we have studied now. Solenoid is in the shape of a helical spring. So like that the particle is moving like this. Helical along a helical path. Particle move due to these two components of velocity. So and the expression also we have. Motion you understood. Due to the component V cos theta, it cover a linear distance. No acceleration. It move in the direction of the field with a linear, with a constant velocity. Linear distance it cover with a constant velocity. That means V cos theta into time. We have to take V cos theta into time. Time period. By the time particle complete one circular motion, we know time period. By that time, it cover a distance. How much distance? V cos theta into that time. V cos theta into that time period. Okay. So here now we can study the equations for that. Motion we understood. Equations we can study. Equations is in this. Here. Equation is here. So due to V cos theta is parallel to the field and V sin theta is perpendicular to the field. Thus the particle moves with a constant speed along the field direction and V sin theta makes the particle to move in circular path. Thus the radius of the circular path R equal to mv by bq. We already derived that expression. R equal to mv by bq, but here it is V sin theta. Not simply V, because because of the component V sin theta, it is completing the circular path. So radius is determined that by that velocity component. So R equal to mv sin theta by bq. Due to these two motions, the particle makes a helical path. Time taken by the particle to complete one revolution, T equal time period 2 pi r, circumference of the circle, by velocity V sin theta. Then we substitute for r. 2 pi by V sin theta into r above we have written r. That is substituted here. mv sin theta by bq. And V sin theta cancel. We get 2 pi m by bq. Very important to remember that formula. Time period. Time taken by the particle to complete one circular motion. 2 pi m by bq. We have to by heart it. 2 pi m by bq. Frequency will be inverse of that. bq by 2 pi m. Okay. So now we got the time taken by the particle to complete one circular motion or one revolution, T equal to 2 pi m by bq. The distance travelled by the particle during this period in the direction of the field. That is what I told. By this time period, particle move a linear distance because of which component? V cos theta. So how much distance it can travel? V cos theta into this time. That is 2 pi m by bq. So V cos theta into 2 pi m by bq. V cos theta into t. T is 2 pi m by bq. So that is the linear distance travelled by the particle in the direction of magnetic field. in the direction of magnetic field. So that is also known as pitch of the helix. The distance, linear distance covered by the particle by the time the particle complete one revolution. By the time particle complete one revolution, it move a linear distance in the direction of the magnetic field. That is known as pitch. Okay, that is important. Pitch. Problems may ask from that. So now we have discussed three cases. In first case, when the charged particle move in the direction of magnetic field. Second case, charged particle is perpendicular to the direction of magnetic field. And third case, the charged particle move making an angle theta with the direction of magnetic field. So the third one is very interesting. It move in a helical path. Charged particle move in a helical path. And its video, which is taken from the end tab, is uploaded in our YouTube. Very interesting to see that. All of you have to watch that. You will get a very clear picture how this particle is moving in a helical path. Okay, you have to watch it. Very good, interesting one. Next is this figure. So we have discussed three cases. Next one, motion of a charged particle in a uniform electric field. Why again electric field here? Magnetic field. We are studying magnetic field. Here again we are discussing electric field, because here when both the field come together, what happened? That we have to study. For that again we are discussing the motion of a charged particle in an electric field. Okay. First chapter we have discussed that. Motion of a charged particle in an electric field. Again we are studying here because the combination of the two fields come. When both the fields are perpendicular, what happened to the charge? Such motions we have to discuss. Because of that we are studying it here. So here you can see an electric field. Electric field direction, all of us know, positive to negative. Electric field, that orange colored equispaced lines you can see that represent the uniform electric field. Two plates are shown, green colored plates, positive plate and negative plate. Direction of electric field is from positive to negative. Charged particle is entering, charge Q, you know, it is entering perpendicular to this field. Perpendicular to what? Electric field. Charged particle is entering perpendicular to the electric field. So what type of motion can you expect? We know when a charged particle is there moving, charged particle is moving, it experiences a force F equal to QE. F equal to QE is the force it experiences. And you know what is the direction of force? F equal to QE. Q is positive charge. What's the direction of force? Is it in the direction or opposite direction? That I will ask question. Charged particle experiences a force QE. It is a positively charged particle. And in which direction it experiences force? Is it in the direction of the field or opposite direction of the field? That's the question. I will ask to Abarna. 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 Abarna, are you there? No answer. Then I'll ask to another one. Ananya. Ananya. Oh, simply wasting time. No one is answering. I'll call another one. Amaldev. Amaldev. No response. No response. Adil Krishna VV. Adil Krishna VV. Anyway, response is there. Okay. Adil Krishna. In the direction of electric. Very good. In the direction of electric field. Charged particle move in the direction of electric field. That is why that motion is shown with the red colored pen, you know, red colored pen. So that is motion, that is moving towards the electric field. And it's not in this level, not downwards. It is moving up because it is experiencing a force and is accelerated in that direction, in the direction of electric field. So that line is drawn upper part, not see, if there is no electric field, the charged particle will hit at the point A on the screen. If there is no field at all, charged particle will hit at a point X on the screen. But when we apply the electric field, it is moving accelerated upwards. That is, force acceleration is equal to force by mass. Force equal to QE. QE by m, that will be the acceleration. Okay, so it will be accelerated in the direction of the field, and it move in a parabolic path. It move in a parabolic path here. So how much distance it move in the field? See, it cover a linear distance. It cover a linear distance. You see, in the x is the distance it has to cover in the electric field, and y is the displacement in the y direction. So let us calculate the force and the y also we have to y equal to ut plus half at square, that we have to find out. A equal to f by m, f equal to QE by m. All such things we have to calculate. Next page. Yes, A equal to acceleration acting on the particle is equal to QE by m. This acceleration is perpendicular to the motion. Another factor. This acceleration is perpendicular to motion. Motion is along the x-axis, but acceleration is acting perpendicular. Acceleration is perpendicular to the motion of the particle. So, as we have seen in circular motion, it will not change the speed of the charged particle, but direction only changes. That is why it moves in a parabolic path. So, acceleration is perpendicular to the motion of the particle. That will not change the speed of the particle, but direction changes. If x is the length of the region of the electric field, time taken by it to cover it is given by time equal to x by v, uniform velocity. So, time you can calculate easily, displacement that x by v you can do. So, time taken to traverse the electric field is equal to x by v. And next if y, not that green box, that other one, if y is the displacement of the charged particle along y direction, then electric field during time t equal to s equal to ut plus half at square. So how much distance it move in the direction of electric field, that is y. Y you can calculate using this formula, y equal to ut plus half at square. And in that, what is u? What is u? Can you tell what is u? I will show the figure again. I will show the figure again. Then you have to tell what is u. So here y we have to calculate. And that from the axis to the point B. B another. Okay. That displacement, how much displacement happens in the y direction? Listen, all my terms you have to listen carefully, then only you can answer my question. So, particle actually it was moving in the x direction. Particle is moving along the x direction. Yes?
ഇപ്പൊ ശിവഗംഗ ഉണ്ടോന്നൊന്ന് നോക്കോ?
ഇപ്പൊ ശിവഗംഗ ഉണ്ട്, ദേവനന്ദ ഉണ്ട്, അരുണുണ്ട്, എല്ലാവരും വെയിറ്റ് ചെയ്യാണ്. ഇപ്പോൾ ഈ മഴയോടുകൂടി നെറ്റ് ഭയങ്കര മോശമായി. ഓക്കെ, listen, all of you listen, and then I'll ask question, you have to answer it. And the answer is in my wordings. Okay, listen. So initially particle is moving along the x direction, and when it was moving along the x direction, we applied the electric field perpendicular to it, and we know the particle experience a force F equal to QE, and it begin to move in the direction of the field, and because of that it cover a linear distance as well as perpendicular, that means along the electric field also it move a distance y distance also it move. Linear distance is covering, it is covering linear distance because of the this here where the here the acceleration. What is acceleration? F by m. Acceleration is perpendicular to the motion. Acceleration is perpendicular to the motion. So here direction is changed. Magnitude of velocity is not changed. Direction is changed. So it move a parabolic path, and it cover a distance, linear distance, that means perpendicular to that, along the y direction. It move a displacement y. Not only y direction, it is moving along the x direction also with a constant velocity, moving along x direction also. So both movement you can see, in parabolic path it move. Okay. So here in order to calculate y means displacement along the y direction. Y means displacement along the y direction. We use the formula s equal to ut plus half at square, or y equal to ut plus half at square. So what is the initial velocity along the y direction when it enter into the field? What is the velocity of the particle in the y equal to uy into t plus half at square ആണ്. uy means velocity, initial velocity along the y direction. What is the initial velocity of the particle in the y direction? Avani, can you tell? No answer. I will ask Badra. No answer. Then I will ask Tejas. My God, no one is answering. Then I will ask Adarsh. Any answer? I'm simply wasting time. I'll call another one. Sanjay can tell. Sanjay also not responding. Okay, then I will ask Namrata.
Yes, teacher.
See, what is the initial velocity along the y direction?
0.
Very good. Okay, 0 is the initial velocity. So we can find out the value of y. Okay. So we can calculate that distance. S is equal to ut plus half at square. In that u becomes 0. Then half into ay. Acceleration is already calculated, qe by m into t also we have to substitute, t equal to x by v. That we have to substitute and square it. Okay. Next page we can take. After this page, this one. Okay. So y equal to 0 into t plus half into qe by m into t square. Qe by m acceleration, t equal to x by v. So square it. So we get y equal to half into qe by m into x square by v square. Then you take x square from it, because in order to show that it is moving in a parabolic path, we are taking x square equal to ky, that form. We are writing that x square equal to a constant into y. So that is the equation of a parabola. That part is constant, 2m v square by q into e. All are constant. For in this particular case, we are not changing electric field. We are the same particle charge to mass ratio, that will be same, and it moves with a constant velocity. So that part is constant. So you can write x square equal to k into y, which is the equation of a parabola. So the particle, when it enter perpendicular to the electric field, it move in a parabolic path. That is proved now. Krishnandu waiting but not able to admit. Low network. Okay. Next, another one. You can see another figure. So that one finished. Now both the fields are here. Moving charge perpendicular to electric and magnetic field. Both the field come. Now what happened? Let us see. So you can see two slits there, S1 and S2 screen, and a slit is provided at the middle point of that, and through one slit. Their axis is same. Axis is same. S1 and S2. Slit. Axis is same and charged particle is q. It is if no field is there, that particle will move along the straight path and it will move along the slit S2. Okay, if there is no field. But we have applied two fields here, electric and magnetic field, and magnetic field is perpendicular to electric field. You can see electric field direction. One is upper plate is positive, lower plate is negative. So what is the direction of the electric field? Positive to negative. Direction of electric field is positive to negative. It is marked that green, that means line of force is drawn, electric field to represent the electric. Only one line is drawn. Actually, we know many lines are there, equally spaced. Parallel lines are there in between the two plates of the capacitor. We have seen electric field is uniform. So here you can consider that as the two plates of a capacitor, one plus q, other minus q. There is an electric field, uniform electric field. And we also apply a perpendicular magnetic field. For example, perpendicular to this field, we keep for example, two poles of the magnet. One pole here and the other side of the mobile, you can say. Another side of the you keep poles, one south pole and north pole. Then it will be perpendicular magnetic field. So into mark represent magnetic field perpendicular to the plane and into that. It is passing into that. Okay. Into means piercing through the mobile like that. Into. So here you can see two field, electric field and magnetic field, both are perpendicular to each other. So you know what will happen. That is, you can see one equation I will show you, then I will explain. Suppose the electric and magnetic field are acting at right angles to each other at a particular region. Here electric field is downward. Electric field is downwards, you know, I showed you, positive to negative, downwards. And magnetic field is perpendicular and into the plane of the paper, that also I told you. Force due to the electric field F equal to QE, downwards. Force due to the magnetic field QEB, it is upwards. You have to apply which law? Fleming's left hand rule, and we can see that it will be upwards. So electric field, force due to the electric field, downwards. Force due to the magnetic field, upwards, QVB. And only those particles move undeflected through S1 and S2 when both the forces are equal and opposite. When upward force equal to downward force, the particle will move along a straight path, that means undeflected. So QVB equal to, in that case QVB equal to QE and B equal to E by B. Only 5 minutes to finish. Okay, V equal to E by B. E by B, and those particles which satisfy this equation, E by B, V equal to E by B, that will pass through both the slits without any deflection. Other particles, what happen? They will be deflected from this straight path. So velocity, it is also known as velocity selector. So those particles which are having this ratio, that E by B ratio, only will pass through the two slits without undeflected. So when both the fields are there, what will happen to the charged particle? That is discussed here. Okay, figure I will show you again. See, this is the figure. Both the fields are there. And I will ask question. Whether I understood or not, that I should know. Vaishak, what is the direction of electric field? Very simple question. What is the direction of electric field in this figure? No answer. Aifa, what is the direction of electric field? Only 5 minutes, please tell. What is the direction of electric field? Aifa. No answer. Steffi, can you tell?
Down.
Downwards.
Downwards. Downwards.
Downward. What force also? Downwards. Force acting on the particle. What is the direction of magnetic field? Kamalesh? What is the direction of magnetic field? Parayo. Sai Krishna? What is the direction of magnetic field? വെറുതെ ഇരിക്കുകയാണോ ശ്രദ്ധിക്കുകയാണോ എന്നൊക്കെ അറിയണ്ടേ? വാട്ട്സ് ദ ഡയറക്ഷൻ ഓഫ് മാഗ്നറ്റിക് ഫീൽഡ്? സായി കൃഷ്ണ. നോ ആൻസർ. അരുൺ? സായി കൃഷ്ണ ആരും പറയുന്നുണ്ട്. സായി പറയൂ. വാട്ട്സ് ദ ഡയറക്ഷൻ ഓഫ് മാഗ്നറ്റിക് ഫീൽഡ്? Magnetic field, force upwards. Okay. What's the direction of magnetic field? Magnetic field. Force upwards. Okay. Field into mark kandille. Into mark represent what? Into mark represents what? Perpendicular and is it outwards or inwards? That is the question. Outwards or inwards? പറ. അപ്പം നിനക്കൊന്നും മനസ്സിലായില്ല. എനിക്ക് മനസ്സിലായി. ഔട്ട്വേർഡ്സ് ആണോ? വേറെ ഇപ്പോൾ ഒരര മാർക്ക് നമ്മൾ അകത്തേക്ക് പോവുകയാണെങ്കിൽ അതിൻ്റെ അറ്റം മാത്രമല്ലേ കാണുള്ളൂ. നമ്മൾ തുമ്പ് കാണില്ലല്ലോ. ഇങ്ങോട്ട് പുറത്തേക്ക് വരുമ്പോഴാണ് നമ്മളതിൻ്റെ ഏരോൻ്റെ തുമ്പ് കാണുന്നത്. അപ്പോൾ ഔട്ട്വേർഡ്സ് എന്ന് പറയും നമ്മൾ. അത് ഓർക്കാൻ വേണ്ടിയാണ് അന്ന് ഞാൻ എളുപ്പവഴി പറഞ്ഞു തന്നത്. ഇത് ഏരോ അങ്ങോട്ട് പോവുകയാണെങ്കിൽ അതിൻ്റെ അറ്റമല്ലേ നമ്മൾ കാണുന്നത് അങ്ങോട്ട് പോകുമ്പോൾ. അപ്പോൾ ഒരു ക്രോസ് മാർക്ക് പോലെ തോന്നും നമുക്ക്. അതേസമയം ഏരോ ഇങ്ങോട്ട് വരികയാണെങ്കിലോ അതിൻ്റെ ഒരു തുമ്പാണ് കാണുന്നത്. അത് അപ്പോൾ ഔട്ട്വേർഡ്സ് എന്ന് പറയും. മനസ്സിലായില്ലേ? അത് ഓർക്കാൻ വേണ്ടിയാണ് അത് പറഞ്ഞു തന്നത്. ഓക്കെ. അപ്പോൾ ഇവിടെ ഈ ഉള്ളിലേക്ക് പോകണത് N2 ആണ് കേട്ടോ. N2 ആണ്. അപ്പോൾ നിങ്ങൾ വിരൽ പിടിച്ച് നോക്കിയെന്ന് വിരൽ പിടിച്ച് നോക്കുക. N2. അപ്പോൾ ഫോർ ഫിംഗർ നമ്മൾ ഉള്ളിലേക്ക് പിടിക്കുക. മൊബൈലിന് പെർപെൻഡിക്കുലറായിട്ട് ഉള്ളിലേക്ക് പിടിക്കുക. ഫോർ ഫിംഗർ. മോഷൻ എങ്ങോട്ട് പിടിക്കണം? മോഷൻ റൈറ്റിലേക്ക് പിടിക്കുക. ടീച്ചർ റെഡ് കൊണ്ട് വരച്ചിട്ടില്ലേ? അതാണ് മോഷൻ. അതിലേക്ക് പിടിക്കുക. അപ്പോൾ തമ്പ് ഇടാൻ നോക്കിയേ. വേഗം നോക്കെല്ലാവരും. ഇപ്പം സമയം കഴിയും. ഓക്കെ. ഓൾ ഓഫ് യു ലുക്ക്. അപ്ലൈ ഫ്ലെമിങ്സ് റൈറ്റ് ഹാൻഡ് റൂൾ. ലെഫ്റ്റ് ഹാൻഡ് റൂൾ. ലെഫ്റ്റ് ഹാൻഡ്. ഓൾ ഓഫ് യു ടേക്ക് ലെഫ്റ്റ് ഹാൻഡ്. ഫോർ ഫിംഗർ ഹോൾഡ്. മൊബൈൽ കയ്യിലുണ്ടല്ലോ, അതിന് പെർപെൻഡിക്കുലറായിട്ട് ഫോർ ഫിംഗർ പിടിക്കുക. N2 ആയിട്ട് പിടിക്കുക. നെയിലൊക്കെ മൊബൈൽ ടച്ച് ചെയ്യുന്ന പോലെ പിടിക്കുക. നെയിൽ N2. ഇനി സെൻട്രൽ ഫിംഗർ ഉണ്ടല്ലോ, മോഷൻ ഓഫ് ദ ചാർജ്. ആ റെഡ് ലൈന് പാരലായിട്ട് പിടിക്കുക. അപ്പോൾ തമ്പ് ഇങ്ങോട്ടാണ് നിൽക്കുന്നത്. ശരൺ, തമ്പ് പോയിൻറ്റ്സ് ഇൻ വിച്ച് ഡയറക്ഷൻ? ശരൺ, തമ്പ് പോയിൻറ്റ്സ് ഇൻ വിച്ച് ഡയറക്ഷൻ? പറയില്ല. മഞ്ജിമ, തമ്പ് പോയിൻറ്റ്സ് ഇൻ വിച്ച് ഡയറക്ഷൻ? Upwards or downwards? Manjima. Abhirami, tell. കഴിഞ്ഞു.